Okay, this is question 23 in chapter 6. It says, you are a member of an alpine rescue team. You must project a box of supplies up an incline of constant slope, angle alpha, so that it reaches a stranded skier who is a vertical distance h above the bottom of the incline. The incline is slippery, but there is some friction present. With kinetic friction coefficient, I'll just say U, coefficient K, use the work energy theorem to calculate the minimum speed you must give box at the bottom of the incline so that it will reach the skier. Express your answer in terms of GH, coefficient K, and alpha. So first we'll just kind of get a picture of what's going on here. You've got your incline with this being H. This is alpha. And that's really all the information we have for the slope. I have that in my notes, so I'm going to take that here. So what we'll start with is work equals Kf minus Ki, or K1 minus K2, or K2 minus K1. See, so the work done by the box would be the work of the weight and the work of the friction. We'll start with the work of the weight, which would just be your force times distance. In this case, it would be mass times gravity times distance, which is going to be h. And that's negative. Now the work of friction is more complicated. The work of friction is going to equal negative F times S, and F can be written as our coefficient of friction times N. And N can be written as your mg cosine alpha. So that's going back to the force coming down on that slope. So that's your N. And your S, back in this equation, can be written as h over sine alpha, which would be your force going this way. Now we're going to rewrite this work of F, your work due to friction force, using these substitutions. So it comes out to be equal to negative the negative coefficient of friction so we just substitute this for N and that for S, which when you multiply that out, you can simplify it a little bit and go coefficient of friction times mass times gravity. We have cosine over sine. Well, let's go under H here. Cosine over sine is cotangent, but we're going to write it as just over tangent of alpha. And that is for work due to friction. Quite a bit. And we're going to make more space. And now we will do our kinetic, well, so we again go back to work equals kf minus ki. Our final kinetic energy will be 0. So you're going to end up with work equals negative 1/2 mv squared. And now we can set these equal to each other because the work of friction and the work of our kinetic energy need to equal each other. Tangent alpha. And we need to solve for v, and that'll give us our answer since we don't have any numbers. So once we solve for v, it looks like, oh, so it should look like this. We have our 2 times coefficient of friction times mgh over mass times tangent alpha, and the square root of all that is negative. So this is the answer I got for is 23 in chapter 6.